Hi, this is Sister Day. I'm wanting to talk about how to use Excel and the future value equation in Excel, future value function, to solve a problem like this one. Let's say we have a savings account where we are going to save $200 every month or per month at 1.72% annual interest rate. We're going to do that for 20 years, and we'll have an initial investment of $300. And that's just a one-time initial investment. From then on, we're just going to put in $200 every month. Well, let's talk about each of the variables within the equation, within the regular compounding interest equation, and how they relate to the variables in the future value function within Excel. So, first of all, in the equation we have years. These are written as 1 year, 2 years, 3 years, and so forth. We're going to calculate it for 20 years. So I'm going to highlight all three of these. I can do that by clicking on one, hold down the Shift key, and click on the last one. That highlights all three of them. And then you'll notice the little box here in the corner. If I grab that little box, I can pull it down, and you'll see that I get a little box that shows me which cell I'm on, what the value of that cell is going to be, and I want to go all the way down to 20 and stop. So now, there we have all of our years, 1 through 20. Now our rate, R, is the annual rate. Here we have it written as a percentage. If you're going to calculate this on a calculator, you're going to need to change the percentage into a decimal, which would be 0.0172. That is the same as 1.72%. In Excel understands when you put a percent there that it means the same as the decimal. So I'm going to put in 1.72%. And the percent was already there because that cell was already formatted to be a percentage. So it knows then that this is actually 0.0172 or 1.72%. That is going to remain the same over the course of all 20 years. So I'm just going to go ahead and pull that down. We could do that, or we could just not do that. We could wait till the end. Maybe we'll do that. Now, N is the number of periods that you are going to compound within the year. So if we're going to compound monthly, the number of periods will be 12. If we were going to compound daily, it would be 365. If we were going to compound quarterly, we would only have N would be 4, and so forth. But we're doing it monthly, so we have 12 N periods a year. Our principal, this is the initial amount that we put in. We're going to put in $300. Now, this in the future value equation, we're actually going to make this negative. We could put the negative here, or I'm going to put the negative into the actual future value equation. Either way, it denotes that the money is leaving us. Even though it's still ours and it's in our own savings account, it's leaving us for the time being, and it's going into that account. So it's going to be a negative in this equation. Okay, that's just one way to look at it. The same with our monthly payment of $200. It, in the equation, when we put it into the future value equation, will be negative. The R divided by N, this is the rate divided by the number of compounding periods in the algebraic equation. This is equal to the monthly rate. In this case, the monthly rate. If we were compounding quarterly, it would be the quarterly rate. So we can do this by hitting equals. We can grab our rate and we divide it by 12. Or, just kidding, let's go ahead and divide it by our number of periods. There we go. That's what we want to do. And it gives us our monthly rate. as a decimal. Now the total number of periods is the n per in our future value equation. This is equal to n, the number of periods, times y, which is the number of years. So in the future value equation, n per is equal to n, right here, times whatever y year we're in. Okay? And now these are all of our variables that are going to go into our future value equation. And if you'll notice, let's just go ahead and let's drop this down. We'll copy it for the second year. So our interest rate stayed the same. The number of periods stayed the same, of course. The 300, remember, this is still just an initial investment. It's not being added to it, but it's calculated each time. That was our initial investment. Our monthly payments have stayed the same, but our n per has changed because now we're not just dealing with 12 periods having been compounded, it's 24. And at the end of the third year, we will have compounded 36 times, and so forth. Let's just go ahead and pull that down all the way to our 20. So at the end of 20 years, we will have compounded the interest on this account 240 times. So now let's go ahead and use our future value equation. I'm going to come here, I'm going to highlight this cell and come over to the FX formula builder. I'm going to click on it. It brings this up. And I can look through here and find the equation that I want to use. Since I have recently used the future value equation, it's right here at the top. So I'm going to double click on it. It puts it automatically into the cell as well as into this function bar. And it has brought up, by double clicking on it, it has brought up this helpful little cell generator that tells me what each variable within the function, what it needs to be, and it gives me a little description of it. You'll notice that it gives an example here that if you have something being compounded quarterly at 6% annual percentage rate, that you would put in 6% divided by 4. But in our case, we are compounding monthly at 1.72%. So we could either type in 1.72% divided by 12, or we've already done that right here. So I'm just going to click on this cell. Now our n per, remember, this is the total number of payment periods in the investment. Well, at the end of the first year, there are 12. So I'm going to click on this cell. This is the number, the n per for the first year. Now the payment. Remember what I talked about, how the payment is actually going to be negative because it's leaving us. And this is our 200. So I put a negative, and I'm going to click on our 200, all within the same line. And our principal value, again, this was our negative 300 right there. Now this last cell is optional. It has to do with when the interest is compounded, whether at the beginning of the period or the end. That is not necessary to this equation right now. It's optional. So I'm just going to omit it and push enter. So we see that at the end of the first year, we will have $2,724.21. Now, due to the beauty of Excel, we can grab the little corner here, and it's going to copy that equation with the corresponding information all the way down. I just drag it and unclick, and there we go. Now it shows that at the end of 20 years, after the 240th month of compound interest and our additional payments each month, we will have $57,664.64. Yay, that's great. Now, let's consider how to graph this. Let me close this out. And if we go ahead, let's graph it. If we highlight this information, we can come up here to our charts, the charts tab, and click on lines. Oh, some of this might go off of your screen. I'm going to choose this first one. Doesn't really matter a whole lot. And it has automatically created a line for me. I'm going to pull this over here so we can make it a little bit bigger. And I can make it bigger by pulling on it. Alright, so we can see it a little bit better. You'll see that if I come along here, it says at point 3 I have $7,699.44, which corresponds right there with year 3. And at the end, if I hold my cursor over it, it gives me the final amount, $57,664.64. So it automatically generates the line for me by just highlighting it and doing that. There are ways to adjust some of these things. If you double click, you can get boxes to come up that will allow you to make adjustments. We can click on here, oops, cancel. You can edit how it looks and things like that. You can also right click on it and do select data, and in there then you can change how things are being featured on the graph. For example, if I want to change my X values to be something else, I could come here and just come there, and let's say I want to do the number of periods that have been compounded. So I'm just going to highlight that. It looked like I needed to double click on that first one and then highlight, and I clicked all the way at the end, highlighted all of those to the end, and hit enter. It automatically puts that in, and you'll notice that my graph changed right there. You know what, I'm going to change my mind on that, and instead I'm going to go back, and I'm going to just do the number of year and enter. And now it's back again to 1 through 20. Also, and this is just one of the wonderful features about Excel, is that you can then play with the numbers. I got this 1.72% by looking up the rate of return on some savings accounts at my credit union, and they had one that had a lot of stipulations associated with it, but that offered a 1.72% interest rate on just a regular savings account, but you could only, withdraw so many times, and there were penalties and things. So it was very restricted. Most savings accounts don't have this high of an annual interest rate. But there are other kinds of investments that perhaps have a higher interest rate. Let's say, for example, you find some kind of investment, wherever it may be. Just kidding, I'm going to just go to the first one. Let's say you get 7% return on investment. All right, I'm going to click that, drag it down, and you'll notice it automatically adjusted all of the numbers across the board, not the ones that didn't matter. It changed the monthly rate, and it changed the future value, and our graph also changed. So you can see what would happen if you invested the $200 every month into something that receives 7%. Instead, you'd end up with $105,396.95. Let's say instead, let's go back to our 1.72%, and let's say instead you decide You know what? I bet I could put in $400 a month. Well, let's see what that does. $400 a month. If we doubled how much we put in, we could end up with $114,906.21 by the end of the 20 years. So you can play with some of the variables in Excel. Let's say, for example, let's go back to our $200 a month. But let's say we started out with $1,000 as our initial investment. What would happen there? Aha! We'd end up with $58,651.80. So you can, that's the joy of Excel, is that you can play with things. You can adjust one thing and it will automatically apply it to the other numbers, as long as you've put in everything correctly. These, of course, were just different scenarios that I wanted to show you. Let's put our 300 back. And we're back to our original values. So anyway, I hope this helps you. I hope that that you can apply it to your own life and figure out how you can save money, or use it in some way in your own life. And if you have any questions, please go ahead and email me. I'm always happy to answer your questions. Have a great day. Bye.